Hello students, welcome to lecture 5 of equilibrium. In last class we have solved some questions regarding calculation of equilibrium constant, homogeneous heterogeneous equilibrium, and if reaction is reversed or multiplied or divided, how the equilibrium constant get changed. These concepts we have cleared by solving these questions. Now in today's class we have to solve very important type of numericals. You can see many such numericals in the examination. It is regarding the calculation of equilibrium concentration or calculation of equilibrium constant of the reaction. Now we have solved some 8 questions in the last class. We will continue with that. This is the question number 9 now, which we are going to solve in this class. So question number 9. Sample of hydrogen iodide. Sample of hydrogen iodide in gaseous state is placed in a flask. Is placed in the flask means container at a pressure of 0.2 atm. 0.2 atmospheric pressure at equilibrium. The partial pressure you know what we mean by partial pressure in states of matter, you will learn that, of hydrogen iodide is 0.04 atm. What is the Kc for given equilibrium? What is Kc for given equilibrium? So they ask us to calculate the equilibrium constant Kc for this reaction. They have initially started with the hydrogen iodide in gaseous state, and when equilibrium is reached, we have hydrogen and iodine in gaseous state. Of course, we can write 2 moles of HI to balance this reaction. Now, initial pressure they are given. Hydrogen iodide is 0.2 atm. Now at the start there is no presence of product, so I write this as 0 and 0. Always remember, at the start of the reaction, if it is not mentioned, product pressure or product concentration has to be taken as a 0. If at equilibrium, what we have to make next is change in this pressure, and then we have to write what is as they have given. We can calculate Kp here because it is in terms of partial pressure. What are the pressures at the equilibrium? At equilibrium, pressure of hydrogen iodide is 0.04 atm. It has been decreased. Why it has been decreased? Because hydrogen iodide has been converted into hydrogen and iodine. So what type of change occurs in this hydrogen iodide? It is negative because it has been decreased. And for hydrogen, its concentration increase and iodine is also increase. let us assume that from this point to ATM, 2x of the hydrogen iodide disappears. Why 2x? Because there is 2 mole. If it is 1 mole, we have subtracted only 1x. For 2 mole, it is 2x. For 1 mole, how much of hydrogen will be appear here? Here it is x and here it is x. So this 0.4 ATM is nothing but this is the value of 0.2 minus 2x. This is the, because initially it was 0.2 ATM and 2x is disappeared from that amount. So equilibrium concentration 0.04 is nothing but 0.2 into 0.2 minus 2x. What is the concentration of hydrogen at equilibrium? It is x and iodine is also x. Now they have asked us to calculate the Kp. So we can write Kp is equal to, by looking into this reaction, pressure of hydrogen, pressure of iodine divided by pressure of hydrogen iodide, square of it, because of this 2 moles. Now we have to substitute here equilibrium partial pressure. We know the value of pressure of hydrogen iodide, which is 0.04 ATM, but we don't know the value of this pressure of hydrogen and iodine, which is x here. How to calculate x? We can calculate x by this term. We can say 0.2 minus 2x is equal to 0.04. That's why 2x is equal to 0.2 minus 0.04. 2x is equal to 0.16. And that's why x is equal to 0.08. So this 0.08 we can substitute here, because that is the value of partial pressure of hydrogen. So I will write here Kp equals to partial pressure of hydrogen is nothing but 0.08. That of iodine is same, 0.08, and hydrogen iodide is 0.04, and square of that. So you can write this as 0.08 multiplied by 0.08, 0.04, 0.04. This is 2 and this is 2. So 2 multiplied by 2 equals to 4. So you can say Kp equals to 4 for this particular reaction. They ask us to calculate Kp and that value comes to be 4 here. So very simple type of these questions are. We have tried the balance equation. Initial concentration they will give in the question. We have to assume that if it is reactant, it is decreasing. If it is product, it is increasing. How much it will decrease? We have to look into the stoichiometric coefficient. If it is 2, 2x, 3, 3x. How much it will appear? If it is 1 mole, x. 2 mole, 2x. If it is 3 mole, 3x. Like that. And then we arrive at the equilibrium concentration. Substitute that in the equilibrium constant. Calculate this. This is the way in which these questions are solved. Of course, more practice is needed. That only we are doing here. So now the next question in this series is the question of chain number. Solve this question 2-3 times, then only you will understand. If you solve only once, you may not understand this, because some difficulty you may face here if you do not understand the concept. So question number 10 here, next question. A sample of pure PCl5. A sample of pure PCl5 was introduced into evacuated vessel. Evacuated vessel at 473 feet. After equilibrium is attained, after equilibrium is attained, concentration of PCl5 was found to be 0.5 into 10 raised to minus 1 mole per liter. If value of K, if value of K is equal to 8.3 into 10 raised to minus 3, what are the concentrations of? What are the concentration of PCl5 and Cl2 at PCl3 and Cl2 at equilibrium? So there is a PCl5 here, phosphorus pentachloride in gaseous state, and it has been decomposed to PCl3 and Cl2 in gaseous state. Initial change and equilibrium. These are three things here. Of course, for us important is equilibrium concentration, because that we are going to substitute. So if we consider this as equilibrium concentration, we are not given this initial and change, let it be. We'll write here only equilibrium only. For PCl5 it is 0.5 into 10 raised to minus 1 mole per liter. Let's assume that this is X and this is X. So we can say that K equals to concentration of PCl3, concentration of Cl2 and concentration of PCl5. K is given, PCl5 concentration is given. This we can calculate. So we can rewrite this equation as K is 8.3 into 10 raised to minus 3. Concentration of PCl3 is X. That of Cl2 is also X. And this is 0.5 into 10 raised to minus 1. So we can write X square is equal to 8.3 into 10 raised to minus 3, 5 into 10 raised to minus 2. X square is equal to, it is 15, 1, 24, 15, 1, 40 plus 1, 41 into 10 raised to minus 5, which we can write it as 4.15 into 10 raised to minus 4. So X is equal to square root of 4 is 2, and that of minus 2 is 1, minus 4 is minus 2. And we can write this as mole per liter. So we can say molar concentration of PCl3 is equal to molar concentration of Cl2, and that equals to 10 raised to minus 2 mole per liter. Capital M is nothing but mole per liter. In that way we can solve this question. So this is also one of the way in which question can be asked. Now the question number 11, we are going to solve different type of questions here. Question number 11. Consider the reaction HI gives H2 plus I2 in gas state. Starting with 0.1 mole of HI. Starting with 0.1 mole of HI in 1 liter container at 800 K, it is observed that at equilibrium concentration of H2 is 0.01 mole per liter. Find out equilibrium concentration of iodine and hydrogen iodide. So once again, the question is regarding equilibrium concentration. Definitely always in the MCQs, NEET or KCT, one of the questions will be of this type. So reaction is given, balanced also. Initial concentration, starting means initial. Change and equilibrium. This type of table. Why do this? What is the initial concentration? 0.1 in 1 liter means 0.1 mole per liter. Hydrogen and iodine, they are 0. Equilibrium concentration of H2 is 0.01. They are given this value. We assume it as X. It is 1 mole 0.01. This is also 1 mole. So this is also 0.01. 2 moles of hydrogen iodide disappears. So equilibrium concentration will be 0.1 minus 2x. They ask the equilibrium concentration of iodine. Already we got our answer, 0.01 molar, because it is same as hydrogen. So equilibrium concentration of iodine is nothing but 0.01 mole per liter. And what about hydrogen iodide? Hydrogen iodide is 0.1 minus 2x. 0.1 minus 2 multiplied by 0.01. 0.1 0.02. And how much half, and they ask the concentration of hydrogen iodide. Yes. So with practice, you will understand what type of questions we are solving here. Now the next one, question number 12. You have to write this question, solve this, and again try to solve. What are entries here? This is x and this is x. So same will remain at the equilibrium, and its value was given, and this value we have calculated. This is 1 mole, this is 1 mole, so same value is for iodine. And for hydrogen iodide, equilibrium concentration is 0.4 minus 2x. X we have substituted, and we get the equilibrium concentration of hydrogen iodide. So I hope you are understanding the methodology. Once you understand the methodology, let the number be first, that doesn't matter. Next one, 1 mole, I just skipped that from prior. 1 mole of acetic acid and 1 mole of methyl alcohol. Where mix that to 298 at equilibrium, .33 mole of acetic acid was found to be unreactive. Found to be unreactive means in that equilibrium. Calculate the equilibrium constant for the reaction. Calculate the equilibrium constant for reaction. They have given reaction CH3COH plus methyl alcohol, esterification reaction CH3COOCH3 methyl acetate plus H2. This is the reaction they have given. So you can write the initial change at equilibrium and calculate the equilibrium constant here. So it is initial change in concentration and the equilibrium concentration. Initial concentration 1 mole of acetic acid and 1 mole of methyl alcohol, product of course 0. If it is 1 mole, X disappears from reactant and same amount is formed X and X because there is also 1 mole. So it is 1 minus X, 1 minus X, X and X. What is 1 minus X? 0.033 mole was found to be unreactive. Means 1 minus X is equal to 0.333. So X is equal to 1 minus 0.333, 0.667 is the value of x. Now we can calculate the equilibrium constant. We can say Kc is equal to molar concentration of methyl acetate, molar concentration of H2O, molar concentration of acetic acid, molar concentration of methanol. This is x means 0.667. This also x means 0.667. This is 1 minus x means that value is given 0.333, and this also 0.333. Roughly it is 2 times. So 2 multiplied by 2, it becomes 4. That is the correct answer here in equilibrium constant. Right, see this question, write correctly calculation part, not at all difficult here. Now see the next one. All varieties were covered. 2 mole of dinitrogen tetroxide were introduced in a flask of 10 liter capacity. Was introduced in flask of 10 liter capacity at 350 K. At equilibrium, 50% dinitrogen tetroxide was found to be dissociated into nitrogen dioxide. Calculate equilibrium constant. Yes. So new situation they are given here, and they ask us to calculate the equilibrium constant in that situation. Dinitrogen tetroxide is in equilibrium with the nitrogen dioxide. So it is initial change in concentration and the equilibrium concentration. Initially 2 mole, but they are not present in 1 liter flask, 10 liter flask. So it is 0.2 mole per liter. Capital M means mole per liter. We have to balance this reaction by directing this, and this is 0. Change will be plus 2x because there is 2 moles present here, and here is x, negative x. X has to be dissociated. At equilibrium, 0.2 minus x, and this is 2x. So how much is x here? The x is given that 50%. X is equal to 50% means 50 out of 100. And how many moles of dinitrogen tetroxide was present? It is present 2 moles. So it is 2, and that's why 0.2 mole per liter was present, and that's why it is 0.1. X equals to 0.1. Then if x equals to 0.1, 0.2 minus 0.1 is 0.1, and 2 into 0.1 is 0.2. Well, everything is clear. We can calculate Kc here. Kc equals to molar concentration of nitrogen dioxide square divided by nitrogen dinitrogen tetroxide. It is 0.2 square, and this is 0.1. So this is 0.2 and this is 0.2 divided by 0.1. This is 2 and this is 0.4. That is the equilibrium constant value for it. What is the unit if you want to give unit to it? It will be mole per liter raised to delta mg. 2 minus 1 is 1, so it is mole per liter. So this is regarding dinitrogen tetroxide. Now the next one, at a certain temperature, if you have any difficulty you can just call. I will explain once again, but you should do homework, solve once again, then only this problem will be clear. At certain temperature, equilibrium constant is 16. For the reaction, one reaction is given SO2 plus NO2 reversely gives SO3 and NO nitric oxide. If we take 1 mole of each of the 4 gases, if we take 1 mole of each of the 4 gases in 1 liter container, what would be the concentration of? What would be concentration of nitrosyl oxide and nitrogen dioxide at equilibrium? This is the question. Every question is different. I have not taken same question 2 times, so that you will expose to different type of questions. If you solve these questions more than enough, you can crack any MCQ in NEET examination and KCET and of course JEE main examination. But thing is that you should understand this, then only it becomes easier. SO2 in gaseous state, nitrogen dioxide in gaseous state. sulfur trioxide in gaseous state, nitrous oxide in gaseous state. Initial change and equilibrium. What they said, we take 1 mole of each of the 4 gases in 1 liter container. 1, 1, not 0, 0. This also 1 and this also 1, because they have given clearly instruction in the question. Change will be minus x because of 1 mole, minus x because of 1 mole, plus x because 1 mole and product, plus x because 1 mole and product. At equilibrium 1 minus x, 1 minus x, 1 plus x, 1 plus x. If it is 0 and it is x, only would have written x, but it is 1 and x, so 1 plus x, 1 plus x, so 1 plus x. Now we can say that Kc is equal to molar concentration of SO3, molar concentration of nitric oxide, molar concentration of sulfur dioxide, molar concentration of nitrogen dioxide. This value is 16. Kc value is given. SO3 is 1 plus x. This is also 1 plus x. 1 minus x. 1 minus x. So 16 is equal to 1 plus x square, 1 minus x square. Square root of both sides. Square root of 16 is 4. Square root of 1 plus x square is 1 plus x. 1 minus x. 1 plus x is equal to 4 minus 4x. X plus 4x. 4 minus 1. 5x is equal to x. 3. X is equal to 3 by 5, which is nothing but 0.6 mole. Now they have asked the concentration of nitric oxide at equilibrium, which is 1 plus x, 1 plus 0.6, 1.6 mole per liter is our answer. And also they have asked the concentration of nitrogen dioxide at equilibrium, which is 1 minus x, 1 minus 0.6, and this is 0.4 mole per liter. So this is very simple type of questions. Practice it. I will give one question as homework, and then I will stop in today's class. But this homework you should do properly, and it will be helpful for you to know whether you are understanding this concept. So compulsory, these questions you have to solve once again 2-3 times. Compulsory do this homework. Two moles of PCl5 was introduced flask and heated at 625 K to establish equilibrium when 60%, we have done this type of question, 50%, now this 60% of PCl5 was dissociated into PCl3 and Cl2. Calculate this. So read this question carefully and try to solve this sincerely, because only when you try sincerely you get answer. Don't think that these questions are very difficult. Of course they are difficult, but if you do not practice them, if you practice, it is one of the simplest type of questions you can crack in the examination. And this type of question distinguish between those who have studied seriously and those who have not studied seriously. If you are able to solve questions on equilibrium, definitely your rank will be increasing in competitive examination, because not so many students will be able to solve this question. So have a patience, practice it. If you are not understanding, you can call and come to college. I will explain you personally, but this should be clear, and give it time. After practicing only you understand. Right, so thank you for watching this video patiently.